Yes. Hi everyone, I am SS Kiran. I am dealing course is electromagnetic waves and transmission lines. Okay. Last videos I have discussed about concepts on electrostatics. In this video, I would like to discuss about the problems on this electrostatics. Okay. Problem number 2. Okay. Problem 2. Right. Consider 2 point charges. 2 point charges, very important. 2 point charges Q1 and Q2 minus 4 microcoulombs and plus 5 microcoulombs are located x1 comma y1 comma z1 located at 2 comma minus 1 comma 3 and another point located at 0 comma minus 4 comma minus 2 respectively. Okay, means minus 4 microcoulombs at 2 comma minus 1 comma 3, 5 microcoulombs located at 0 comma minus 4 comma minus 2. Okay, respectively. Now the question is, find the potential V. Find the potential at point, another point 1 comma 0 comma 1. That's it. There is zero potential at infinity, assuming. Now the discussion about the solution starts with the solution. Okay. Now the first point Q1 equal to minus 4 microcoulombs is nothing but minus 4 into 10 to the power of minus 6 coulombs. Another one Q2 equal to 5 microcoulombs is nothing but 5 into 10 to the power of minus 6 coulombs. Now, if V infinity equal to 0, then C naught equal to 0. Our formula, potential formula, V naught of R or V equal to, here two charges are there. The first one is Q1 by 4 pi epsilon naught, 4 pi epsilon naught. Actually, this is R. Now here I will calculate the mod. So R bar minus R1 bar. Another charge, I will go with another charge, multiple charges, go with the summation Q2 by 4 pi epsilon naught R bar minus R2 bar. Okay. So there is 2 points. The first point 1 comma 0 comma 1 2. Then 2 comma minus 1 comma 3, another point 1 comma 0 comma 1 2, 0 comma minus 4 comma minus 2. Now calculate one by one. No need to take this constant term is 0. Now finally first calculate R bar minus R1 bar. Very simple calculation. No need to take line equation, all those things. Simply I can write this expression. Please go through it. So there is a point is 1 comma 0 comma 1. Okay, minus 2 comma minus 1 comma 3. This is another point. Now doing some mathematical part, 1 minus 2, there is answer is minus 1. 0 minus 1, the minus of minus 1, then 1 comma 1 minus 3, there is answer is minus 2. So point with mod. finally root over 1 square plus 1 square plus 2 square. Now the final answer is root over 6. About this r bar minus r1 bar. Then I will go with r bar minus r2 bar. Same calculation. Okay, 1 comma 0 comma 1. This is 1 point. And the 5 microcoulomb point at 0 comma 4 comma minus 2, right mod, then doing some mathematical part. So what is the resultant point? 1 comma minus 4 comma minus 4 comma 3. We'll take the point symbol. Then root over 1 square plus 4 square plus 3 square. The resultant is 26. Okay, now substitute these two values in this expression 1. At the same time, this Q1 and Q2 values also. Now take common of 1 by 4 pi epsilon naught. V of r equal to take common 1 by 4 pi epsilon naught. Then take Q1 charge. But you can take this microcoulombs also, 10 to the power of minus 6. This one also very important. Okay, now the resultant is 5. The first one Q1 is minus 4 microcoulombs. Already microcoulombs taken common. This resultant is simply I can write root over 6 plus 5 microcoulombs, 5 root by 5 by root 26. Okay, there is another expression is there, 1 by 4 pi epsilon naught equal to 9 into 10 to the power of 9 farad per meter. Okay, then doing some mathematical part, then final resultant. Okay, then V of r equal to substitute this part, then minus 10 to the power of minus 6 and 10 to the power of 9, then resultant is 10 to the power of 3. The resultant is 9 into 10 to the power of 3, 9 into 10 to the power of 3. Doing some mathematical part in between this minus 4 by 6, that is the resultant is minus 1.633 plus 5 by root 236 means 0.9806. Okay, the final resultant is minus 5.872 kilovolts. This is the potential. Okay, then I will go with the next problem. Very interesting problem, that is called problem 3. Problem 3. Last video I have discussed about problem 1 also. Please go with my description. Let's verify my channel. Okay, problem 3. Very simple problem. Consider 3-point charges. Considered 3-point charges. Considered 3-point charges. One is the minus 1 nanocoulomb. Nanocoulomb means 10 to the power of minus 9. Another point is 4 nanocoulombs. And the third point is 3 nanocoulombs are located individual points x1, y1, z1 located at 3 different points respectively, 0, 0, 0. Another point 0, 0, 1, and these 3 nanocoulomb located at 1, 0, 0 respectively. Very, very important word, respectively, right? Respectively. The question is, find the energy in the system. Find the energy in the system. This simply you can write, find the energy W. You know, the one familiar formula is there about this energy. W equal to three works are acting here, W1 plus W2 plus W3. The first work done, because of there is no further movement of charge, this W1 work done becomes 0. Now W equal to the first work done is 0. Then go with the next one. The next one, actually the W equal to first one 0. The next one is Q2 with respect to V21. Already I have discussed it in electrostatics energy density electrostatics. I have discussed this concept in last video. Please go through it. Then another point, Q3 with respect to potentials, V31 plus V32. Now a little bit elaborated of these two expressions in respect to VT1. Okay, the first point, W equal to first one is 0, then Q2, just simply we can write charges, that we will substitute the values Q2 by Q1, Q1, then actually initial you have to write 1 by 4 pi epsilon naught, but we can take common, not common, Q2, Q1, Q2 like that, 4 pi epsilon naught. Now the resultant Q1, already Q2 is there, now Q2 into V, Q2 into Q1 by 4 pi epsilon, okay, 0, 0, 1. Because of this V21, already I have written this one, V21 is equal to Q1 by already 4 pi epsilon not taken common, then take one bracket here, 1, 0, 0. This is one point. Another point is 0, 0, 0. Then close this bracket. Okay. Now better you can take this one. Now it is very easy to understand about this bracket. Clarity is very, very important. Right? Now, this plus 3 you can write as it is Q3 by 4 pi epsilon naught. Same here, same point. The 4 pi epsilon naught is also common. 4 pi epsilon naught is common. Then take a little bit long bracket. We have to write 2 points because V31 plus V32. Now Q1 by 1, 0, 0. This is one point. We have to write mod also, very, very important. Mod also. Okay. Mod also. I will extend this one. This bracket and the mod because of better clarity. Okay. Mod. Very, very painful. This bracket. Okay. Here also can take mod 1, 0, 0 minus 0, 0, 0. Another point. Same. Take long line plus Q2 by mod 1, 0, 1, 0, and bracket close, 0, 0, 1, and then mod, take the bracket. Okay. Attend the 2 points. Just I will Emulate this one, very simple. Now, this 1 minus 0, 1, 0 minus 0, 0, 1, 0 minus 0, then finally 1 square. 1 square root of 1 is answer is 1. Now extend this method. W equal to 1 by 4 pi epsilon naught take common, direct take common. 1 by 4 pi epsilon naught. Then take Q1, Q2, then directly you can write Q1, Q2 by, so there is root over this one, 1 square, 1 square plus 0 square plus 0 square. No need to further extension. Okay, then I will take another one plus Q3, Q1, same phenomena. I will go with the same phenomena. Root over 1 square plus 0 square plus 0 square. Then take plus another one, Q3 into Q2, multiply Q3 product with Q2. Now here it will get extended. So 1 square plus 0 square, 0 minus 1 whole square, 1 minus 1 whole square. The resultant is 2. The final resultant is W equal to 1 by 4 pi epsilon naught Q1 Q2 plus Q3 Q1 or Q1 Q3, no issue. Q3 Q1 plus Q2 into Q3. This is I'm rearranging the point charges. This is to root 2. This is root 2. Now I have to substitute this Q1, Q2, Q1 values. The Q1 value equal to minus 1 nanocoulomb, Q2 value to 4 nanocoulomb. Now the meaning of nanocoulomb is 10 to the power of minus 9 coulombs. Here two charges are there. So two charges are there. Then implies 3 charges 10 to the power of minus 9 into 10 to the power of minus 9. The resultant is 10 to the power of minus 18. Then rest of things substitute as it is. Now W equal to 1 by 4 pi epsilon naught bracket is 4. Minus 4 into 1, minus 4 into 1 means Q1 equal to 1, Q2 equal to 4, 4 into 1 minus 4. Here I will substitute minus 4. Okay, then take another one plus what is the meaning of Q3? Q3 is 3 nanocoulombs, 3 into here Q1 1, then I will write minus 3. So minus 3 nanocoulomb, then take plus Q2 means 4, Q3 means 3, 4 3s are 12. 12 by root 2, then multiply with nanocoulombs Q1, Q2. So Q1, Q2 means 10 to the power of minus 18, where 1 by 4 pi epsilon naught equal to 9 into 10 to the power of 9. Now doing some small mathematical part, W equal to 9 and this 9, this 10 to the power of 9 with 10 to the power of 90 is written as 10 to the power of minus 9. Okay, then this is this rearrange this term 12 by root 2 minus 4 minus 3 is written as minus 7. After that, doing small mathematical part, W equal to 9 into 10 to the power of minus 9. This one is doing some mathematical part. This root 2, take the one, better take calculator. This 12 divided by root 2. Simply you can write root 2 value 1. Root 2 12 divided by root 2. Once again I will recheck. Okay, 12 divided by 12 divided by root 2 1.1 1 second root square root. Answer is 1.414. Then go with 12 divided by 1.414. Okay, this is 8.48 something. Anyway, the result is after doing all the mathematical part. No need to write all those things. This minus 19 can written as nanocoulombs. Nanocoulombs. I will rearrange this one. I need to multiply with 9, right? The resultant is 13.7 13.37 nanojoules. Okay, this is the work energy system. Right? Please save this problem. Then I will go with the next one. I will take new slide. This has to be with number 15. Very, very important. 15. Save. I will delete the old one. Okay, now I will start with the new problem. Very interesting problem based on the capacitance. Not only capacitance, the wire diameter, conductivity, energy density, current in wire, drift velocity of the electrons. Okay, now I will discuss about problem 4. Okay, after this one, I will stop this video. Problem 4. A wire diameter 1 mm and conductivity is 5 into 10 to the power of 7 moles per meter or Siemens per meter as 10 to the power of 29 free electrons per meter cube when the electrons per meter cube when an electric field, very, very important, when an electric field 10 millivolts per meter is applied. This is the data given by the examiner. Is applied. Now the questions are determine the first parameter is the charge density rho v. The charge density of the electrons, This is the first question in this problem. The second one, the current density. The second one is current density, simply J bar. Very, very simple formulas. Current density. The current in the wire. The third bit is the current in the wire. The next discussion is the drift velocity of the electrons. Very, very simple. The drift velocity denoted with U. No need to write a complete matter. Then I will go with the solution part. The first one is charge density. Simply, the first one is charge density, simply denoted with rho v. Rho v means number of electrons, simple. So the number of electrons equal to 10 to the power of 29, 10 to the power of 29 given by the examiner. Nothing to worry. Charge means Q minus 1.6 into 6 something minus 1.6 into 10 to the power of minus 19. Doing some small mathematical part, then we will get the resultant charge density of the electrons minus 1.6 into 10 to the power of yes 10 coulomb per meter cube. The meaning of meter cube volume. The second bit is current density denoted with J bar. Current density, okay, denoted with J bar equal to very simple. J bar equal to sigma E bar. J bar equal to sigma E bar. Sigma is simply given 5 into 10 to the power of 7. Sigma given the examiner 5 into 10 to the power of 7. E bar equal to is already given the examiner. So directly I will return this one. 10 into 10 to the power of minus 3. Doing small mathematical part, the J bar equal to 500 kilo ampere per meter square because of the density meter square. In the third discussion, C equal to current. The current in the wire I equal to very simple Js. Then J is already given the just now derived this J. The final 500 is kilo 10 to the power of minus 3. S means this area. Simply I will write the formula 5d squared by 4. 5d squared by 4. So substitute all the formulas. D square value is D square means 1 millimeter. D square means 1 millimeter. So finally 5 pi by 4 into 10 to the power of minus 6 because of D square into 10 to the power of 5. So the resultant is 0.393 amperes. Okay, the last one is velocity. Very simple discussion. B equal to velocity. Actually, the actual formula J bar equal to rho v u. Then u equal to J bar by rho v. Then J bar equal to 5 into 10 to the power of 5 by rho v equal to 1.6 into 10 to the power of 10. Okay, the resultant is 3 into 125 into 10 to the power of minus 5 meter per second. Okay, these three problems are very important problems. Okay, keep watching. I will discuss more number of concepts in this EMWTL. Thank you.